This is section 9.1, probability distributions and expected value. We are going to be using our calculator for this. All right, so let's look at this first one. 4 coins are tossed. The number of heads is recorded. Shade the region on the histogram that gives the indicated probability. The graphs on my math lab are going to be multiple choice. So I'm just going to sketch one out. That's why I'm not an art teacher. So the probability that you have 4 coins and that 0 are heads, you have 1 head, 2 heads, 3, or 4 heads. Okay. The probability that X is less than or equal to 3. Less than or equal to would be 0, 1, 2, or 3. The line underneath the inequality sign means it's equal to. Probability that X, the number of heads, is less than or equal to 3. It's going to be this. So let me see if we can do another. I'm just going to pull one up here. Let's say the probability that X is greater than 2. So more than 2 heads. It doesn't have a line underneath the inequality. So it's greater than 2. So that's going to be 3 and 4. Whereas this one, X is less than or equal to. The line underneath the inequality means equal to. So that's 0, 1, 2, or 3 heads. So the one we had on the right, the probability X is greater than 2. There's no equal to on this one. It's just going to be greater than 2 would be 3 and 4. Now, if there was a line underneath it, that means 2 would be included, and then you would have 2 shaded as well. So it's going to depend on which version of the problem that you get. So just be careful with those inequality symbols. 3 cards are drawn simultaneously from a deck. So you pull 3 cards at once. You're not pulling out a card and putting it back or anything. The number of spades is counted. The probability distribution is shown below. Draw a histogram for this distribution and shade the region that gives the probability of more than 1 spade. So more than 1, does that include 1 or not? So more than 1 will be 2 and 3. So let's get an idea what this chart would look like. All right, so this is 4, 1, 3, 5, 4, 3. So let's just say this is at 4, 1. The probability of 1 spade is just a little bit higher. The probability of 2 spades is 0.1376. And then the probability of 3 spades is pretty small. So that's what 0, 1, 2, and 3. That's what the histogram looks like. So this is 0.4135, 0.4359. I just don't have room right out of those. 0.1376 and 0.0129. So the higher the probability, the higher the bar. And they want to know, shade the region that gives the probability that it's more than 1 spade. And we said that was 2 or 3 spades. Just a little messy. So 2 or 3 spades is going to be right there. So similar to the one we did before. All right, 2 names are drawn from a hat, signifying who should go pick up pizza. Two of the names are on the swim team and two are not. The number of swimmers selected is counted. Draw a histogram and show the region that gives the indicated probability. All right, two names are drawn from a hat, signifying who should pick up pizza. Two of the names are on the swim team and two are not. All right, so we're going to have the histogram. So let's look at this. We're going to have to do a little tree diagram first. Okay. So our totals, we have swimmers, we have two, we have non-swimmers that are two. We're going to pick two people. All right. So we have the probability you pick a swimmer on the first go is 2 out of 4. Okay, because the total is 4. Not 2. But the probability they're a swimmer is 2 out of 4, which is 1/2. The probability they're not a swimmer is also 2 out of 4 because there's 2 non-swimmers out of 4, and that also reduces to 1/2. Not a swimmer is also 1 out of 2. It's 2/4, and that reduces to 1 out of 2. So the first time you draw a swimmer, so on the second draw, the probability you pull a swimmer is 1 out of 3 because there's 3 people left. And then if you pull a swimmer the first time, the probability you pull a non-swimmer is 2 out of the 3 that you have left. So let's look at this a little bit differently. Now down here, the first time we pull a non-swimmer, so the second person we select, the probability they are a swimmer is 2 out of 3 because we have 2 swimmers out of 3 left. And the probability they're a non-swimmer is 1 out of 3. Okay. All right, so the number of outcomes, so let's look at this. This would be a swimmer and a swimmer, swimmer and a non-swimmer, non-swimmer, swimmer, non-swimmer, non-swimmer. All right. So the probability with 0 swimmers is 1/2 times the 1/3. Okay, that's here. So probability 0 non-swimmers is 1 out of 6. The probability there is exactly 1 swimmer. Yeah, okay, so it would be this combination, this combination. So 1/2 times 2/3. Plus, we also have this combination here. There's 2 of them. 1/2 times 2/3. And that is going to give us, when it simplifies, 2/3. The probability that both the people you pick are swimmers is right here. That's going to be 1/2 times 1/3. It's also going to be 1/6. Oh, I didn't leave myself enough room. I'm going to go back up here. I'm going to erase this chart. Again, this is a video, so you can stop it and come back. So let's make a distribution table. Probability of 0, 1, or 2 swimmers. Okay, that's 1/6, 2/3, and 1/6. So let's look at this. Okay. Should be a little, that should be more like halfway. All right. So that's what the bars would look like. Let me make this a little bit neater. And it should be like half. All right. So that's the histogram, but they want to know, they want you to shade right here. You have fewer than 2 swimmers. So that would be 0 and 1. Fewer than 2 swimmers are selected. So that's just going to be 0 or 1. Let's see. We need to find the expected value. So I'm going to write something down here. This is for your calculator. So we're going to put the X value into L1 and we're going to put the probability in to L2. And I'm going to show you how to put that in your calculator. So let me get over to that. Sorry about that. See if I can get it without it becoming bigger. There we go. All right. So we're going to hit, as I hit these buttons, we're going to hit stat. We're on edit, so we're going to hit enter. If you have anything in L1, I'm going to show you how to get rid of it. Arrow up till you're on L1, hit clear, not delete, hit clear, and then hit enter, and it clears the whole column. If you hit delete, it's going to get rid of L1. It's not a big deal. I can get that back. Or you can type over. When the probabilities go into L2, then you're going to hit stat. You're going to go over to calculate. And it's one var stats. It's one variable. We only have one variable, not 2. Don't be confused because we have 2 columns. Your list is L1. Your frequency list is going to be L2. So that's going to be second and then number 2. And then go down and hit calculate. And your expected value is the X with the bar, that's your mean. So the expected value, ours was 3.3. And it should be somewhere in the middle. So when we get this, like for the next one here, we have 9 through 21. Our expected value, for the most part, is going to be somewhere in the middle. It'll be between 12 and 18. Okay, it's the average. So let's do this here. L1, L2. If you don't have the 84, you can use the view the example. It's going to take a little bit longer, but it is possible. Okay. So let's get the calculator back up. Here we go. Scoot it over. Right. So you're going to hit stat again, and you're on edit. So you're going to hit enter. So you can clear it or you can type over. Just hitting enter after each one. Arrow over and go up. Double check. You pull the 0 off the 0.20, that's fine. That's not a big deal. And I'm going to show you one more time. If you just wanted to clear out the whole column, put your arrow up to L1, hit clear, don't hit delete, hit clear, and then hit enter, and it clears the whole column for you if you prefer to do that. All right, then we hit stat, go over to calc, it's calculate, 1 bar stats. Frequency list is list is L1, frequency list is L2. With these calculators, the last thing you put in there is going to stay in there. So then we're going to hit calculate. And X with the bar above it, that first one, that is our mean. That is our expected value. And I said it was going to be somewhere in here, between 12 and 18, pretty close to 15. Okay, that is the average. It will vary depending on, this is pretty symmetrical. Okay. Find the expected value for the random variable X having the probability function shown in the graph. All right, same thing we just did. This would be your L1, and this would be your L2. All right, so 10 goes up to 0.35. 20 goes up to 0.25. 30 goes up to 0.2. 40 goes to 0.15. And then 50 is down here at 0.05. So let's get our calculator out. So we hit stat, we're on edit, so we hit enter. And I'm just going to type over. So I'm hitting enter after each one. Arrow to the top. Gonna double check my numbers are correct. Looking good. So we hit stat, go over to calculate, and we're on 1 bar stats. Hit enter. Again, L1 is our list, our frequency list is L2, that's our probabilities. Hit calculate. So that average is going to be 23. Okay. Average should be somewhere between pretty much those middle values. It's more heavily weighted on the lower side, so that's why it's 23 as opposed to being more towards 30. All right, roulette wheel. One option in a roulette wheel game, a roulette game, is to bet $40 on red. So betting $40 on red. There are 18 red, 15 black, and 2 compartments that are neither black nor red. So red is 18. Black is 18. Other, they don't tell us what color they are. That's going to be 2. If you add those up, there's 38 total slots on the roulette wheel. If the ball lands on red, you get to keep the $40 that you paid to play, and you are awarded 40. If the ball lands somewhere else besides red, you are awarded nothing, and the $40 that you bet is collected. Okay. All right, we win. So we pay $40 to play. If we win, we get our $40 back, plus we win $40. So how much are we up? You are up $40. you're over here. All right, if you lose, you pay $40. All right, so the probability that you win, all right, red constitutes a win. So it's 18 out of 38. Okay, so the top is red over the total. The probability that you lose is going to be 20 out of 38. So these are not red, so that's the black and the unknown colors. And then 38 is the total. Okay. The probability you win is 18 out of 38. If you win, you are up $40. We're going to add this to the probability that we lose, which is 20 out of 38. And if you lose, you are down or negative $40. We can put this straight in the calculator. It's going to take me a minute. So second mode. Oops. Hit math. Mean over 38. If you don't want to put the fraction bar, you get 20 divided by 38. Just make sure you keep it inside the parentheses. We're going to lose 40, so you need to use negative, which is below your 3 on the calculator. Again, negative is below the 3 on the calculator. If you put a minus, it's going to give you the wrong answer. All right, so we need this in terms of money. So if you hit the math button again, you see it says fraction and you go down, that's decimal. Number 1 converts a number to a fraction. Number 2 converts it to a decimal. So hit enter again. So you expect it to lose $2.11. So expected value is negative. We don't need the dollar sign. $2.11. We're dealing with money, so we're going to round to 2 decimal places. In a certain animal species, the probability that a healthy adult female will have no offspring in a given year is 0.31, while the probability is 1, 2, 3, or 4 offspring are respectively those numbers. Find the expected value of the expected number of offspring. All right. So 0 offspring, 1, 2, 3, and 4. That's 0.31, 31% chance they're going to have none. 24% are going to have 1. 17% are going to have 2. 16% 3. 12% are going to have 4. Okay, again, this is going to be L1. This is going to be L2. All right, you notice that the higher probabilities with 0, if you were to do a histogram, it's going to 2, 3, 4. So your average is going to be closer to 1. It's going to be somewhere between 1 and 2. So stat, we're on edit. Again, I just want to type over. And if you wanted to get rid of the whole column, arrow up to L2, hit clear, do not hit delete, and then hit enter. Whichever method you prefer. And double check my numbers. All right. So then stat, go over to calculate, 1 var stats. We have the regular list in L1, the frequency list, which is our probabilities in L2, and hit calculate and enter. So the expected value is 1.54 offspring. And remember in my math lab, wherever you put the answer underneath there in blue, they tell you what to round to. So make sure you check that. The used car dealer gets complaints about his cars, as shown in the table. So number of complaints per day and the probability. The most he gets in a day, the highest probability is 4 complaints. Um, and it kind of goes down from there. So I would say the average is going to be between 2 and 5, between 3 and 5, actually, probably closer to 3. Okay, but most of your expected values are going to be right there, pretty much in the middle. So again, this is going to be L1. This is going to be L2. Stat, edit, and let's see, how many was it? 1 to 6. I'm just going to type over. Probabilities in. Let's do this over. 16 and 04. Oops. Double check. So again, stat, calculate, 1 bar stats. List is L1, frequency list is L2, our probabilities, and hit calculate. Oops. Let me see what I did. Okay, quit stat. 0. Okay, I forgot to start at 0. When it says dimension mismatch, what it is, I have one value without a corresponding one. So I forgot the 0. So let's try this again. Stat, calculate, 1 bar stats. So the expected number of complaints per day, or the average, is 3.5 per day. I believe. Okay. Yep. That is it for section 9.1.